Okay, today we're going to be looking at right triangles. And here Seth says, well, these two triangles are congruent because there's two pairs of congruent sides, AB and D. AB is congruent to DE, AC is congruent to DF, and a pair of right angles, so that by side-side angle, those are congruent. But what is Seth? He's an angle side-side because you can't use side-side angle, okay? But there is a type of side-side angle we can use that we'll get to in just a little bit. Now, Jay, on the other hand, says, well, I know by the Pythagorean theorem that c squared equals a squared plus b squared. And c squared and a squared and b squared, b would have to be 3. Okay? So that side has to be 3. So if each of these sides are 3, if this is 3 and this is 3, then those triangles are congruent by side, side, side. Yep. I like Jay's thinking. Okay? Now, Seth is sort of right, but you can't use side, side angle. There's something that we're going to get to today called HL. HL stands for hypotenuse leg. If the hypotenuse of this side is congruent to the hypotenuse of this side, what's an hypotenuse? The longest side of a right triangle or the side opposite the right angle, either way. Okay? If a hypotenuse of one triangle and a leg of one triangle are congruent to the hypotenuse of another triangle and the leg of another triangle, then the triangles are congruent by hypotenuse leg. So we add a 5th way, and that is all we'll get to is 5 ways of proving triangles congruent. Okay? So if you have a hypotenuse and a leg of a right triangle, and it has to be a right triangle. It can't be just some willy-nilly triangle. It has to be a right triangle. If you have a hypotenuse leg of one triangle congruent to a hypotenuse leg of another one, then those two triangles are congruent by hypotenuse leg. Okay? So, why are these congruent? By hypotenuse leg. Is there enough information to say that we have HL here? No. What else do we need to know? That YZ is 6. If YZ would be 6, then we can say hypotenuse leg. Okay? Here's a long proof, but I'm not going to go through the whole thing. I'm just going to show this is really important. If AF is congruent to AF, that's a reflexive property. So if you have a side that's the same in two triangles, okay, that is the reflexive property. So understand that that's a reflexive property. You'll see HL when you get enough done. Also, if they say in one step things are perpendicular and then the next step they're 90 degrees, that's the definition of perpendicular lines. When they say certain angles are 90 degrees and then in the next step they call the triangles right triangles, that's the definition of right triangles. Okay? So when you see a proof like that. And then the step after HL or SSS or SAS is generally CPCTC when you say parts of it are congruent because the triangles are congruent. Okay? So, ways to prove right triangles are congruent. We can prove them by side angle side. Okay? We can prove right triangles by side angle side if we know two sides and then the right angles in between. We can prove them congruent by angle side angle if we have the right angle and another angle and a side in between. We can prove right triangles congruent by angle angle side, 2 angles and then some random side. And then we can prove right triangles congruent by hypotenuse leg. Okay? Or we could prove them congruent by side, side, side if you would know all the sides of them. Okay? So, basically, the only different thing today is we're proving triangles congruent by hypotenuse leg. And you'll have a lot of right triangles. Some of them will prove by SAS and various other means. Okay, so I will let you get started. We get out of here at 17 after, so you don't have a lot of time to work. This is not due until Tuesday, so you will have a Monday study hall to work on this if need be.
I will get it done in 5 minutes.
I'm glad you will.